Yo, what's up, guys? Welcome back. Another video, another day, another video. I think this is episode 49. I'm pretty sure. Sorry I haven't made a video the past 3 days. I was out of town for Valentine's Day with my girlfriend. Had a really fun weekend. I just got back yesterday, a little late, so I had to go to work, and then I was very tired and went straight to bed. So couldn't make a video yesterday or over the weekend. So it's been probably at least 3 days since we made a video. Yeah, probably gonna be a little bit of a quicker video today. I played some tennis again today, and I am so tired. Had to help out at practice and actually play, so I am exhausted because I don't do much physical exercise anymore, which is totally on me. But I'm quite busy, just trying to code and just get better with my data structures and kind of work on my own stuff in my own spare time. But yeah. So we're probably gonna be a short video, probably about an hour long. Maybe 2 or 3 problems depending on our time. Probably a little bit of a long video tomorrow. But yeah, let's get straight into it. Pokemon number 49. It's kind of looking. What do we got here? Venomoth. Nice. Let's take a look at the sound. Oh, jeez. Bless me, bless me. Oh, jeez. Sounds like a dinosaur a little bit. Yeah, that was a weird sound. I don't know. I don't even know how to do it. Yeah, that's going to be my attempt at it. We'll listen one more. Oh, that's it. Okay. Okay. Nice. Little Rust video I was watching earlier. Yeah, let's take a look at our problem of the day. God, that is bright. Jeez. God, I hate the homepage, man. It needs to be black. I'm going to take a look at this problem here. The kth lexicographical string of all happy strings of length n. Interesting. A happy string is a string that consists only of the letter ABC. SI does not equal SI plus 1 for values of I from 1 to in the end of it. ABC, AC, are all happy strings, and strings A. Okay, so I think they're talking about the adjacency here, so you can't have duplicates right next to each other. Given 2 integers n and k, consider a list of all happy strings of length n sorted in lexicographical order. Return the kth string of this list, or return an empty string if there are less than k happy strings of length n. Let's take a look at a couple of the test cases here. So we got n is 1, that's why we have c here, so we want to get the third happy string, I guess you want to call it, of length 1. So in this case it would be c. If we have 1 here and k is 4, obviously we only have 3 numbers, so I think that's why we return the empty string here. There are only 3 happy strings of length 1. Okay, yeah, so it's not possible, it's out of bounds. Here we have n is equal to 3, and we have k is equal to 9, so we need to... So this kind of gives it away here straight away. I was originally kind of thinking of a set maybe for these duplicates, but now that I see this here, realize this is a recursive problem or a backtracking problem. They got to backtrack to complete all these test cases here. So yeah, so I guess here we're gonna have a res here to store all our strings. I mean, there's some different ways that you could probably do it. I mean, but we're gonna do a simple way with a result array. What else are we gonna need here? We're going to need our backtracking function, right? So let's initialize that. We're going to take in a current. We want to call our backtracking function, right? We want to probably pass in an empty string. Trying to think, what else would we need? think we're good for now. I guess we'll kind of get into it. So probably our base case here. So gotta think about our base case here in our recursive problem. The base case would be, I think here really is if I guess if the length of cur is equal to n, then I guess we just want res.append cur. I guess we just return nothing, right? We break. We have a recursive case here where, you know, we're going to have to loop through here. So char and array, we want to check, well, if char does not equal, we got to think about the adjacency here. So if char does not equal oh, we need our array here to initialize that. We need to initialize an array with all these numbers in it. The reason why we're doing this because we're given, these are the only 3 numbers, right? List consists of only of the letters of the set. Okay, right. So we got this. What our recursive case here? So, you know, for char and array, check, well, if char does not equal array char plus 1, char plus 1, then I guess we want to just want to append, well, char.append I, right? I think, no, char.append, what am I doing, char.append, cur.append, or should we maybe call our backtracking function with char plus our string here, char plus cur? I don't know. And obviously we want to return, well, we have our values of given 2 integers and a k gets a list. Well, let's just return res for now. Let's see what it returns. Return res. Let's see what we get here. Can only concatenate string, not integer to string. I don't know how to do this here. Let's take a look over here. I think it's because Okay, so it says here, I think we're on the right track here. We had this incorrect here, so so that's what I was thinking. I just didn't really know how to explain it. I kind of thought this. So obviously we have our char here. You know, we're indexing, you know, a string here. So what does it say here? Char is a string. Oh, char is a string. Yeah, for char and array, right? We're looking at the array. Not an index. So array char plus 1 is incorrect. Yeah. Because we're indexing with a string, it's not an array. Okay. So here it's telling me to check, well, first of all, I didn't think, but we gotta check if the array, if not cur, we need to check if cur is empty, right? So we check if cur is empty because, you know, if it's empty, we don't need to check the adjacent, right? So we don't want to miss that. Right? If not cur, or we want to check, well, this is where we messed up. We need to check, well, char does not equal char minus 1. Sorry, not char minus 1, cur. Cur minus 1. Then we backtrack here. Let's run this. It's no attribute copy. Oh. Let's get rid of that. It's probably only for nodes. Okay. We got A, B, C, right? So we appended all the ones with that length. So now we need to do, well, we would return res k minus 1, right? We want to return this value here, so we'd return, well, what's our k? We'd end in k is equal to 3, right? So we want to return the third digit. We return, well, k minus 1 would reference this value here. Return k minus 1 if k is less than or equal to the length of res, else we return the empty string. Is that how you do it? Is this how you do it? I think this is correct. I think this should work. Oh, there we go. I got it. See, does this work? Ooh. What are we missing here? Output AAC. Output CAD. I don't know. What are we missing here? I forgot to change this. So we need to follow the Lexi graphical order. I wonder if that'll fix it. There you go. That fixed it. That was an interesting problem. I mean, I'm kind of happy that I kind of thought about it in that way, I guess. I'm actually feeling really happy that I solved that. So that was a good, you know, kind of getting the idea of backtracking, you know, having that base case, and then nice. Yay. Oh, that makes me feel good. Okay. Let's take a look at some of the other problems of the day that we missed. Oh my gosh, what did I just do, dude? Bro. Okay, daily question. Construct all numbers. What the hell? Zero index string num of length n+1 is created using the following conditions. Num consists of digits 1 to 9, where each digit is used at most once. Bro, why does my headset keep powering off? Oh, I got a new headset, by the way. My roommate's cat ate the cord. A little bit upset, but you know, they gave me half, which I thought was, you know, to be honest, I kind of think it's more his fault. I mean, the whole thing, I mean, it's his cat ate my item, or like broke my item. I feel like that's not really my fault, but it's okay. It is what it is, but num consists of digits 1 to 9, where each digit is used at most once. If pattern I is equal to I, then num's I... If pattern I is equal to D, then num I is equal... Turn the lexicographically smallest possible string num that meets the conditions. Right. So... I'm kind of confused what is going on here. We have a pattern here, which is increase, 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 decrease, increase, decrease, decrease, decrease. So we increase here, 1, 2, 3. Then we decrease and go to 5. What the? Or do we always start at 1? You're given a zero index string pattern. Well, what else do we give him? Oh, we have to generate the number ourselves. A zero index string num of length n+1 is created using the following conditions. Num consists of digits 1 to 9, where each digit is used at most once. Okay. Decrease, decrease, decrease. 4, 3, 2, 1. What the? That 4, 3, 2, 1 is the smallest possible num that meets these conditions. Oh my gosh, dude. Do we have to generate all different possibilities? Bruh. Are you serious? Like, this is quite a tough problem. I kind of think about it a little bit. Like, I mean, let's take a look at the backtracking. Yeah. I mean, as soon as I saw this, bro, like, and I knew some possible values of the number 9876, 7321, and 8742, it can be proven that 4321 is the smallest possible num that meets the conditions. Like, bro. We're looking at another backtracking problem. So that's interesting. I think this problem is a little tougher than the other one. I mean, you're kind of working through a lot. I mean, you could... I mean, bro, like... I mean, how is this the smallest possible number? I mean, can't you start 1, 2, 3, 4? Why are we going from 1, 2, 3, 4? 1,234 is smaller than 4,321, so is the smallest possible number that meets these conditions. Pattern decrease, decrease. You can't increase. Okay. 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 I understand. You can't decrease from 1. So, the reason why it's increase, increase, increase is that we're increasing from 1, 2, 3. Then at indices 0, 1, and 2, and 4, we must have num i's less than num I plus 1. At indices 3, 5, and 6, and 7, we must have that num i's greater than num I plus 1. Okay, this is definitely more of an interesting problem here, but we're going to define our backtracking function here. We're going to attempt this problem. I'm probably not going to get it, but, you know, we're going to attempt it. You know, I think the way we're going to do this is that we're going to have our res array here. That's where we're going to put our values. we're going to have our backtracking function here, and I think our base case here is most likely going to be, well, if the length of, if res is equal to the length of pattern, right? I mean, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, length. Sorry, yeah, it says here that it's the length of n plus 1 of pattern plus 1. And I guess we just want res then we're kind of just appending the whole thing. Well, let's just append each number in there, right? So we'll do res.append. We'll append here, and then we'll return, right? So we're gonna append when current is a copy, right? So we'll pass in cur, and we'll initialize again the same, that cur, we'll call backtrack here, and we'll pass in an empty string, right, to begin with. Okay, and then we're gonna return the min value in our array res. Right? So think about it here, our recursive case. How do we do this here? So, well, this is where I think I'm going to struggle. You know, we have to think about two possible things here. We think about I and we think about D. So, well, if I is equal, if pattern I is equal to I, then num I is less than num I plus 1. Which is, yeah, that's true, but you know, we also can't implement duplicate values either, so maybe the best bet is that we make cur a set. I don't know. I don't know if that's the best. We're going to take a look at it here. With the constraints, could we generate every possible string? Yes, we can. We just need to check if the string meets all the conditions. Okay. Nice, bro. Thank you for that. That is a... the more you fear something backtracking, the more it will happen. How can this be 80% acceptance rate? Interesting. Well, let's think about this here. Like, we have our recursive case here. Well, we want to start, well, pattern I is equal to I, then nums I. Well, obviously we're going to have to, that's an egg. We're going to do well for char in pattern, right? And I check well if pattern char is equal to I, then and else if pattern char is equal to decrease, maybe we need our cur to be set, potentially. You know, I'm thinking maybe changing this to a set where we do our cur is equal to set, right? We pass in cur. I think that's how this should work, right? Because then we don't have to really worry about duplicate values here. You know, we can return maybe not. I don't know. Like, I mean, I just don't really kind of know. Each digit is used at most once. Maybe we could check, well, if pattern is equal to I, then we just want to return, well, we want to do cur.add I think we kind of want to add the smallest value that we can possibly do that's available, right? Smallest value possible. Add the smallest value possible that's available, right? I think that's what we have to do here for I, right? With D, we need to check, well, we need to think about, well, like, what is the best value? What is the smallest / best possible value that's available? Right. I think that's what we need to think about here. This I'm not sure how to implement. I think this is easy to implement. This one let's try and do that. Add the smallest possible value that's available. So I guess I'm not sure actually. Let's take a look at what we got so far. What is this called? Let's 2375 construct smallest number from DI string. Is this so far correct? Oh my gosh. This is meant to be cur. Whoops. Okay, that's our first thing. Incorrect use of set for cur. Set is unordered, but we need to build an ordered sequence of digits. Instead, cur should be a list that stores a number being constructed. Okay. So we were wrong here. Not a set. We want it to be a string. I mean, a array here, or a list. Okay, we want to track the index. So for I in range length pattern, we want to check, well, pattern I. Oh yeah, well, I don't know why I was doing the other one. I mean, you want to track the index. That was so stupid of me, but okay. How do I implement this correctly? Use vectoring. Yeah, choose numbers from 1 to 9 while ensuring increasing. Pick a larger number than the previous one. Decreasing, pick a smaller number than the previous one. Use a used array to ensure digits aren't repeated. Stop when the first valid result is found, since we need the lexicographically smallest number. Okay. Jeez, man. Oh, got another power off. Okay. So it looks like we kind of did the recursive case incorrectly. A little bit. I mean, we were kind of thinking about it right, but I guess a better way is to probably loop over the range. It looks like here that they used is equal to false times 10. Okay, so they're tracking the digits using a array with Boolean values in it. That's interesting. I wonder. This is an interesting way that to kind of think about this problem. I didn't know it was this much code, but let's take a look at some of the solutions. Maybe there's an interesting one. Let's take a look at this one. What are they doing here? Yeah. He uses a stack here. Wow, okay. So he creates n is equal to the length of pattern. Result is equal to this stack for I and reason for one stack dot append I plus 1. If I is equal to n or pattern I is equal to I, whilst. That's an interesting solution. I didn't think like really a stack was. Did they even have that here? Like topics. Oh yeah, stack. Okay. Stack and backtracking, super easy, most optimal solution. I didn't even notice that it was a stack. Everyone here uses a stack. Interesting. 5 lines of code. 3 lines brute force. Return min, join p for p and permutation. Like, bro, how is this readable, bro? Like, well, what does this mean here, bro? If all GTLTQ is equal to I. Jeez, man. I don't know if anyone got to this part of the video, but man, this is confusing to read right here. Like, looks like they use a stack here as well. Interesting. I kind of wasn't really thinking about a stack for this problem, but I'm trying to think here. Well, maybe we can kind of think about a stack after stack way, but I'm going to finish it using the way I was going to. Here it looks like they use okay. So I suggested that it should maybe use a set. I'm curious to... Still looping through. If num in used, skip row to use numbers. If current pattern linked code minus 1 is equal to I and num is less than... Interesting. So here they use a set here, right? So the same base case, I mean, we got the base case right, but instead here that we're looping through pattern, we want to loop through, well, length curve -1. Okay, so that's how we keep track, right? So I guess here we can loop through for num in range 1 through 9. This is kind of the way they want to think about it, right? Oh, 1 through 10, sorry. Oops. Looks at numbers 1 through 9, right? So let's check. Well, if num in used, then we want to continue, right? So that's if num in used, continue. Okay. Why are we checking all the numbers though? I thought. Okay. If cur and pattern if cur and pattern length -1 is equal to I and num is less than cur -1. I don't know what this is doing. Pattern length cur. Okay, so we're checking. Okay, so we're checking the value here that we're looking at. If it's equal to I and num is less than cur -1, then we continue. If cur and pattern length cur -1. So we're using this here. We're checking if cur is not empty, right? So if cur has something in it. Sorry, if cur has something in it, and then the pattern length cur -1. So we're checking, well, what our cur is at, right? Is, you know, the value that we're looking at, the I, or what is it, D? The I or D that we're looking at in our list here, in our pattern list. So this gets to what we're looking at. So if it's equal to I, and then we want to check, well, is num less than cur -1? If not, if we do this, we continue, right? Then we want to do the same, but for the length here is equal to D, and num is less than cur. Sorry, it's greater than. I think that's the only thing we need to switch here, right? So on, then we continue, right? Because if it is, if cur and pattern cur -1 is equal to I, and num is okay, it keeps going through, right? So then we want to do, well, use.add num. So I guess we're checking here if it's incorrect, right? So if we're, I'm cramping, jeez. We're checking if cur has something in it, and then we're checking, well, at the area that we're at in our array pattern that we're checking is equal to I, and then num is less than the current number before, then we don't want to add that. We want to continue, right? And it goes the same way here. If it's D, but it's greater than the one before, then we don't want to add that, and we want to keep looping through until we find one that is, you know, smaller or greater here in this case. So then we mark if we do find one, right? Else if it is, right, and we do find one, we want to append that to a used value. We want to append to num, and then we want to backtrack passing cur, right? And then we want to stop early if we found a valid result. If res return. Why are we checking if res here? I don't understand that. We're going to pass this here right now. We're going to pop here. and we're going to do use.remove. Alright. I'm going to pass in, well, just an empty array here in this case. I'm going to return res0. We need to fix this here because we need to change this into a string here. So dot join cur map string cur, that list to a string. Okay, let's take a look at what this returns. Num is not defined. Did you mean nums? Yes, I did mean nums. I guess this is meant to be num. Got num for everything. Set.remove takes one argument. Use.remove. Oh, whoops. Use.remove num. Whoops. This index is out of range. This index out of range. Res0 in smallest number. Why is it out of range though? Oh, I think this could be a reason here. If res no return. I think maybe that's what I mean, I'm missing that here. I'm curious to see if that's what it is. Our index is still out of range. You know, I'm not sure. I don't really know what this is doing here. If res, like, why are we checking incorrect base case check? Oh, sorry, if the length of cur. Do we need this? I don't know. Let's take a look. I don't know. Let's submit. Let's see if this passes. Okay, it does pass. I want to kind of break down this recursive case here. I understand this part here, right? But I just don't understand. I understand that we use.add num and cur.append num, and then we backtrack, right? Then I don't understand why we're removing here. That shows uniquely since each number can only be used once in the sequence. We skip continue, right? Okay, if cur handles increasing, then the next number must be greater than the last number in cur. Violation increases range. We skip this num. Handles decreasing. So I think I understand why now it's doing this. So Okay, I understand now. So I had to get a few clarifications. So here we're using. I honestly didn't think about this, but every time we're like obviously recursively calling backtrack, we're restarting our for loop from 1, to check those numbers, right? So we can find the smallest value every single time, and then here obviously we pop because, there might be a better way, potentially in the recursion tree, right? It's hard to kind of think about, and to be honest, I can't think about it fully, to be completely honest with you. I do understand what the code is doing, but it's just a little hard to think about, for sure. We're going to take a look, at something else. We're actually going to post this solution because I don't think I saw one like this. Let's post this solution. Okay, let's just submit it again, right? What about our solution here? Let's post it because why not? We need to obviously think of a clickbait title. It's a slow solution, so probably no one wants to look at it. Let's just post it like this. I honestly don't really mind, but yeah, whatever. Okay. Anyway, let's take a look at a stack approach. Let's kind of think about this. This is going to be my last problem for the day, but let's kind of think about it in a stack approach sort of way. As really nice way to think about that, right? So here we want to obviously create a stack, right? Now how can we use this kind of using a stack? Well, to be honest, I have absolutely no idea. If I'm being completely honest, I have absolutely no idea how we can use a stack here. It doesn't really come to mind. Maybe recursively adding the numbers to the stack, potentially. I don't know, because we're always, if we recursively add the numbers, then we're always kind of looking at the top of the stack to see if it's, if we have an I now or a D, then we're looking for something lower or higher than that. I don't know. Jeez, I mean, I don't know. The lightning fast solution. Let's take a look at this solution. So this guy here loops while he creates a res. Right, he has a stack here. Add I to process last num start at 1 for smallest. For I and char and enumerate pattern plus I start is equal to 1. Stack.append string I. While stack and char is equal to I, res plus or equal to stack.pop. one line solution, bro. What is this, bro? Like, bro, like, how is this even like? Can't be shorter. Bro, these guys are too sweaty, bro. Like, how do they come up with these like one line solutions? I don't understand. Like, is this guy cracked, bro? I have no idea. Like, I mean, bro, dude. Bro, does this guy miss a day, bro? Oh my gosh, dude. Jeez, dude. This guy solves problems all day, bro. Oh my gosh, dude. He never misses a day, dude. Eat pizzas. Man, I wish I was as good as this guy, bro. Look at this, dude. Oh my gosh, bro. 2024 every day, bro. I don't think he's missed a day. Badges for every month, dude. 365 days, 500 days badge, bro, dude. Bro, insane, bro. Insane. Started in July, bro. His first submission in July of 2023. Bro. Every day, dude. Jeez, man. Incredible, dude. Incredible that there's people like this. I mean, bro, that's crazy, bro. Like, 1,602 problems. Man, I wish I was as cracked as that, but that's okay. You know, we'll get there one day. Yeah, I want to look at his. Yeah, I lost his solution, dude. Nope. Which one was it? Yeah. I like this guy's solution here. So you have to think about it here. So I and try and enumerate pen plus I start is equal to 1. Pattern plus I is equal to 1. Stack. Smallest, okay. Whenever an I increase appears, pop numbers from the stack to form the result. This efficiently ensures that D sequences get reversed, while I sequences are added directly. Interesting. Holds numbers to be reversed. For I and try and enumerate pattern plus I. We iterate over the pattern, but we add an extra I at the end to ensure the last number is processed correctly. Numbers start at 1, ensuring the lexigraphically smallest result. Variable I represents the next number to be added. Add the current number to the stack. Every number is first pushed onto the stack. If the pattern contains D, this delays by adding the number to res, so that decreasing sequences can be reversed. If the pattern I, or when we process extra I at the end, we pop numbers from the stack and append them to res. This ensures that the numbers delayed by D are added in the correct order. If the pattern was D, I'm still a little confused here, to be honest, when reading this. For I and char and enumerate, we're looking for I and we're looking for char. So we want, obviously, the index, and we want char and enumerate pattern plus I, start is equal to 1. We stack dot append string I, right? So while the stack and char is equal to I, Man. Trying to think here. So I don't know. The extra I at the end. This extra I apparently ensures that everything gets processed. So we start at 1, right? Stack.append I, right? So we append I if it's D, right? So we just keep appending I D. While stack and char is equal to I, we pop. Okay. I instantly added if char is equal to I. When char is equal to D, I is held and reversed. Okay. Let's take a look at this problem here, right? Well, let's take our paint here a little bit. Okay. So we have our stack here, right? Let's just kind of look at this ourselves, right? So let's say we want to look at, I think I understand what's going on, but we're going to, let's take a look at this one here. So let's create our test case here. We have I. God, my eyes are bad, man. Let's redo that. Let's make that neater. We have I again, right? We have D, we have I, we have D, we have D, we have D. Okay. I'm gonna take a look at this here. We can't start from 0 because of digits 1 to 9. Yeah, that's what I thought. Okay. Okay. So let's take a look here, right? So we have, this is our order, right? So we do for I and char, and then you write pattern plus I, right? So technically we have the plus I over here. So let's just add that over here. We start at 1, right? Stack.append string I, right? So we see an I. We just instantly, while stack, so while there's something in our stack and our char is equal to I, we append. But either way, there's nothing in it, we append, right? So we append 1. I think here, right? Let's grab this test case. Okay, so we add I. Okay. Okay. So we're gonna add I, stack.append string I, right? Then we're gonna go to while stack, so that's something in our stack and char is equal to I. Let's make our res array here. We're gonna res is equal to 1. Res plus or equal to 1. Let's actually go over here and do it. It's going to be a long one. Res is equal to 1, right? Sorry, this is meant to be a 1 here, I guess. We're going to pop this, right? Then we're going to go back, right? So we're going to check, well, we got I again. And now we're at 2 now, right? So we're going to append 2. And we're going to pop it instantly again. You know, because our char is equal to I, so then we're going to have 2. We're going to add our I again. Just 3, and we're gonna pop. then we're going to get 3. I jar enumerate pen out was 1 stack pen out while stack and char is equal to I res plus is equal to stack dot pop. I'm going to pop again, right? And then we see a D, right? So we see a D, and then we want, well, you know, we don't want to append it, right? So let's add our D, right? So we add 4. We don't do anything. Then we add it. We have an I, right? So we add 5. While stack, we pop, right? So we get rid of this. We pop. And we have 5 here, right? Okay. Then we add 3 Ds, right? So we're gonna go through this fast. We have 3 Ds, so we're gonna add 6. We're gonna add 7, and we're gonna add 8, right? Right, 6, 7, and then 8, right? And then we're going to add I, which is our final value. In this case, we're going to have okay. We're going to add I here, which would be technically be 9 here, right? 9, and then while stack and char is equal to I, we're going to append these values, right? I'm going to pop every single value. So we go boom, 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 boom. So we go 9, 8, 7, 6, 4. Oh. Okay. We messed this up already. That's not good. Let's go back. I didn't read the code properly. That sucks, right? So we had 1, 2, 3, right? We pop everything. Then we see our first D. We add 4. Then we go here. And then we have our I here. We have 5, right? So while stack and char is equal to I, we keep popping, right? So we'd pop, we'd add 5, and then we'd add 4. We pop both since it's a while loop. I didn't think about that. Then we come here and we keep adding numbers. We had 6, 7, 8, right? We make our stack here in this case. Terrible stack, sorry. Now we have our last 9, right? And then we append 9. Okay. And then we just pop 9, 8, 7, 6. Because we go into our stack, we see an I. We use the I here to generate our last number, 9, 8, 7, 6. And let's see what we got. 1, 2, 3, 5, 4, 9, 8, 7, 6. So that's a great way to, I mean, bro, like, I don't understand how you think about this on top of your head. It's actually really impressive, to be honest. Man, I mean, the math that comes is just interesting, you know? So let's try and code that up here. So we have our stack here, and then we have, well, we want to do for I and char in enumerate. Then we want to do our pattern, and we want to add plus I to it. And then we got another condition here. We want to start from 1. So iterating over pattern with char and I over pattern. Let's do plus I with I and char starting from 1, right? So we loop, okay. We obviously want to stack.append string I. Then you want to check, well, if there's something in our stack and check while stack and char is equal to I, we just want to, well, pop from the stack. So stack.pop then we do, well, res.append. We got res string here. Res is equal to this. Res.append. Res.add? Or is it res.append? I don't think I have it anymore. Oh, that sucks. Okay, I'm gonna do res.add and and obviously we want to return our res. Let's take a look at this. Oh, attribute add, is it? Oh, it's, sorry, not add. I think you do plus or equal to. And I think we can do this in one line. We can just do stacked up pop like this, I think. Let's take a look at this. There we go. Sweet. If you want to check stack has something in it, and char is equal to I. Ignoring okay. I'm gonna submit the solution. That was a really great solution. It was easy to understand, easy to follow. We beat 100% here. Okay. We're gonna call it here, guys. I appreciate you guys watching. You know, we're gonna be back at it with some more problems tomorrow. So, see you guys tomorrow morning.